Like I said, our test is on Friday. So all of the review that we're going to be doing this week is specifically designed to help you out on the test. Okay? So if you're sitting here on your Chromebook, that's fine. That shows me, again, that you know everything for the test and you're confident, which is great. So that's good to see, if that's the case. If not, I mean, it's your choice. So 6.3 is the last lesson we talked about in this unit, and it's all about comparing functions. So taking two separate functions and looking at what's similar, what's different, all that good stuff. So here, we've got Manuel and Carmine going on a road trip together, but they're going in separate cars. Now this table here represents Carmine's journey. But this graph over here, this represents Manuel's journey, right? So you may have noticed, hey, these points don't match up with these points. That's right, because they're two separate functions, right? So we're going to have to find the unit rate and the initial value, or the slope and the y-intercept for each person's trip. Let's start with Carmine's trip. First thing we have to do, obviously, is fill in the rest of this table. We can see here that our change in y from 100 to 150 is what?
50.
Plus 50, right? And what about our change from 2 to 3?
Plus 1.
Plus 1. Right? So if we're going to go one step before this, we'd have an x value of 1 and a y value of what? 50. Perfect. Is that our y-intercept right there? No. Some of you may have put that as our y-intercept. Our y-intercept is wherever x is equal to 0. So we got to go one more step back. And where does that take us for the y, Azalea? Right back to 0, right? If we're adding 50 to the right, we just had to subtract 50 to the left and subtract 1 to the left, just like that. If we're going the opposite direction, we do the opposite sign. And then our last number over here is going to be 250, right? So our slope, Carmine's slope, is going to be 50 over 1. Right? 50 over 1, and the b value is going to be 0. Now let's take a look at Manuel's road trip here. Manuel starts at 0. So what is our b value going to be for Manuel's function? 0, right? Now the slope, a lot of you may have gotten 1 over 1 here for Manuel's slope, because if you look at the graph, you can see from one point to the next, you're going up 1 and over 1, right? But we're not exactly going up 1. We're actually going up 60. From 0 up to 60, right? Each notch on this graph, on the y-axis at least, is worth 60 units. So you can think about it like we just squished the graph down so we could fit all those numbers in view without messing up the x-axis here. So we got to keep in mind the scale, or the numbers that we see lining our y-axis, all right? That's going to change what our rise is. So we rise up 60 units and we go over from 0 to 1, that's 1. So our slope is 60 over 1. What do those two numbers represent though? 50 and 60. What would the units on those numbers be? Anyone know?
Miles.
Hannah? Miles per hour, right? Thank you, Theo and Hannah. Miles per hour. Take a look. The y value is miles and the x value is hours. So if we put y over x like we do with the slope, we get miles over hours. So if Carmine's driving 50 miles an hour and Manuel's driving 60 miles an hour, question B is asking us which individual is driving faster. Who is driving faster? Manuel, right? Now, after 7 hours of driving, who is farther from their home? What do you guys think? Manuel once again, right? If Manuel is driving 10 miles an hour faster than Carmine, then it doesn't matter how many hours of total driving they've done, Manuel is always going to be ahead of Carmine, right? So he's always going to be the one who's further from their home, unless those speeds change at all, which in this case they are not. They are not. Now, a way that we could have confirmed option or number C here was we could have expanded our table out 2 more spaces, gone 6 and 7, 300 and 350. And then we could have looked over at 7 on the x-axis here, and we're lined up at 420. So we would have seen that Carmine, after 7 hours, is 350 miles from home, whereas Manuel is already 420 miles from home. Therefore, he's a lot further from home than Carmine, right? Any questions on number 1? A lot of thinking involved, but yes. Yes. Does anyone else not have this paper in front of them right now? Okay.
Shake it, John, shake it. Hold on.
Show thumbs, how are we feeling about number 1? Uh-oh. Only a couple thumbs up? That's not good. Oh, okay, there's more. So you're going to see something pretty similar to number 1 on the test on Friday. Just keep that in mind. Definitely keep this worksheet safe once I pass it back, just so you can have it to use on the test if you'd like. Down to number 2. Getting rid of the whole context of the problem, what's going on. Here we're just comparing 2 functions. So we take a look at f of x. Remember this idea we talked about on Friday, f of x. It's the same thing as saying y is equal to this function, except when we have 2 functions, they can't both be equal to y. So one of them is equal to f of x, one of them is equal to g of x, as we see here in the table. What's the slope of f of x, Azalea? 1 over 3, right? It's the number right in front of x. That's always going to be our slope. What's our y-intercept, everybody?
2.
2. Thank you. We're going to wait right there on that one. Let's head over to g of x. We can fill out this table. How do we get from -4 to -5? -1. And how do we get from 1 to 2? +1. So our slope here is going to be -1 over 1. What's our y-intercept going to be here? -3, because we're looking for this number right here, the y value when x is equal to 0. And if we're subtracting 1 each time, we'll add 1 going to the left, and that gives us -3. And then the last box is going to be -6, right?
Yeah.
I did the compare wrong.
Now we have to compare. Now comparing these 2 functions requires us to do a couple of things. The first one being, are these proportional or non-proportional? And are they linear or non-linear? So let's start with f of x. Is f of x linear?
F of x is not linear.
F of x is not linear? You see an exponent in our equation? I don't see any exponents here, so I don't know what you guys are talking about. This is definitely linear. 1/3 x plus 2. No exponents there, right? It's only nonlinear if you see exponents in the equation, right? Now what about g of x? Is g of x linear? How do we know g of x is linear? Because it definitely is linear. We don't have an equation to look for exponents, but what were we able to find?
A constant change.
A constant change in x and y. We were able to find a slope, right? If we can find a slope at all, it's immediately linear, because only straight lines can be measured with slope. So it's definitely linear. Now, are these 2 functions here proportional or non-proportional?
Non-proportional.
Why do you say they're non-proportional?
Because the b value is not equal to 0.
The b value is not 0, so this is non-proportional. There's the first part of our comparing. The second part of our comparing is we have to compare what? Anyone remember?
That's the steep.
The steepness, right? We've got to compare the steepness of these 2 lines. So what number are we going to look at? Are we going to look at the slope, or are we going to look at the y-intercept when determining steepness? We're definitely going to look at the slope, right, Azalea? So let's take a look. Our slope here is 1 over 3. Our slope here is just -1, right? Now, 1/3 and -1. Again, we're looking for which number is bigger, right? Regardless of the sign. So forget about the negative on that 1 for a second. Imagine it's 1/3 and just 1. Which of those two numbers is bigger? 1, right? 1 is definitely bigger. We get rid of the minus sign. 1 is bigger.
Yeah.
So we know that g of x is steeper. And that's the big comparison I'm looking for you guys to make, okay? You still have to note whether it's linear or proportional or nonlinear, non-proportional. But the steepness is the big part. Because that shows me you understand that if we have a fractional slope, we've got a more horizontal line. And if we've got a whole number slope, we've got a lot more vertical looking of a line, right? Questions on number 2? Very nice. Let's take a look at number 3 now. Very similar, but a little bit different. What's our slope for f of x here? 0. Is that our slope or is that our y-intercept? Negative 10 is our slope and our y-intercept is 0 because we don't see any number being added on the end. Therefore, it must be just a plus 0, right?
Yeah.
Let me take a look at the next one. What's our change in y from 0 to 1? Plus 1. Yes. And what's our change in x from 6 to 3? Minus 3, right? So our slope is equal to -1 over 3. And then what's our y-intercept here? Positive 2, right? If we move this plus 1, we get to 2. And our y-intercept is wherever x is equal to 0, right? So f of x, is f of x linear? Yes, it is. I don't see any exponents. Is f of x proportional? Yes, it is. This one is actually proportional. No b value, right? Or b value is equal to 0. What about g of x? Is g of x linear? Yes, we found a slope. Is g of x proportional? No, it's not. Our b value is not 0. It is non-proportional. Which one of these is steeper, though? F of x or g of x? Give me a thumbs up if you say f of x is steeper. Give me a thumbs down if you say g of x is steeper. Which of the two? Good. Of the thumbs that I do see, I see all thumbs up. That's correct. F of x is steeper here because 10 is bigger than 1 over 3. Again, ignoring the negative signs. Don't even worry about the negative signs. Pretend they're not there. Look at the numbers. Which one's bigger? Whatever one's bigger, that line is steeper.